Hydrochloric acid solution can be neutralized by using lime, which is calcium oxide. How many kilograms of calcium oxide are required for the neutralization of 35.50 gallons of a 2.40 molar hydrochloric acid solution? Two important things with the information given in the problem. First, we are told that we have a neutralization reaction occurring, so we're going to have to write a balanced chemical equation for that. Our base is the calcium oxide, and our hydrochloric acid, of course, is the acid. The second item that we have to take note of is the fact that our volume of hydrochloric acid is given in the English unit of gallons. We need to convert that to liters, and of course, to do the stoichiometry, we need moles of hydrochloric acid, so we're going to make use of the relationship molarity times volume is equal to moles. So let's start by writing the balanced chemical equation, and I'm going to scroll down and give ourselves a little room here. Our reactants are hydrochloric acid, HCl, aqueous. That's reacting with calcium oxide, which is a solid. And our products are going to be calcium chloride, CaCl2. We have an ordinary metathesis reaction, and our other product is water, H2O, liquid. Balancing the equation, I need a 2 in front of the HCl, and we're good to go. Now, we're going to need some more information on our starting points for our reactants. As I mentioned, we need to convert our gallons to liters. So, looking up in the book, we have a relationship that says 1 gallon is equal to 3.785 liters. So, let's make that conversion right up top here. We have 35.50 gallons of hydrochloric acid solution. We're going to multiply that by 3.785 liters per 1 gallon. My gallons cancel. And doing the multiplication here, I get 134.4 liters of HCl. So now I've converted our volume in gallons to our volume in liters. So let's now do the stoichiometry part. Let's assign values to our two reactants here. Since we have our balanced equation, we really don't care about the product, so let's just ignore them. All the action is going to be to the left of the arrow. The information now that we have about our hydrochloric acid, we are told that we have a concentration of 2.40 moles per liter, so let's write that there. And we just calculated the volume in liters, 134.4 liters. Multiplying these two, of course, is going to give us our moles, which is what we're going to do. We're going to convert that to moles of hydrochloric acid, convert that to moles of calcium oxide, convert that to grams of calcium oxide using the molar mass of calcium oxide, and then the problem asks for kilograms, so we just do a metric conversion there from grams to kilograms. Since we do need the molar mass for calcium oxide, we can look that up and calculate the value for that, and it's 56.08 grams per mole. So now we have everything we need, so we can set up our problem, do the calculation. Either way, we'll start with our measurement of volume, which is 134.4 liters, so let's write that, 134.4 liters. Times, now we're going to multiply that times the molarity of 2.40 moles per liter. Liters cancel. I now have moles of hydrochloric acid. We're going to convert that to moles of calcium oxide. So we look, of course, at the coefficients in front of the two reactants. 2 moles of hydrochloric acid gives us 1 mole of calcium oxide. So I'm going to write 1 mole calcium oxide for every 2 moles HCl. A little sloppy, we should put our HCl here. So we keep our chemicals sorted out. Now I have moles of calcium oxide. I need to convert to grams. Molar mass comes into play. 56.08 grams per 1 mole calcium oxide. Moles of calcium oxide cancel. I got grams. Now we're simply going to convert to kilograms. We can scroll up. 1 kilogram over 10 to the 3rd grams. Grams cancel. Now we've got everything we need. We've got kilograms as our only unit upstairs. We do the math, and we come up with our final answer of 9.04 kilograms of calcium oxide needed to neutralize the 35.5 gallons of hydrochloric acid. Our answer, of course, has three significant figures. That's due to the molarity concentration, three significant figures, smallest number of sig figs in our calculation.